Hello, thanks for coming back for another episode with me. Today I'd like to talk to you a little bit about cannabis heat units, which is an observation I've brought from experience, but also that I've just seen in other crops. So it's no mystery that it would apply to cannabis. I've discussed this on some other people's podcasts and that too in the past, but why not explain it once more with the evolving thoughts that have come with it as people have given me feedback and stuff. And I'm also going to invite you all to help me in the study of cannabis heat units. So we'll be able to classify every cultivar by how many heat units it needs to finish, rather than just days to finish or weeks to finish or harvest date. Because as we've seen, in a warmer year, certain crops will finish earlier than in a colder year, or they might not finish at all. So in two crops that have many parallel considerations would be vinifera wine grapes for the growing degree days or degree ripening days, depending on what your preference is. But these can be calculated in either Fahrenheit or Celsius. And usually they subtract a base layer. So in Fahrenheit, they subtract 50 degrees. In Celsius, they subtract 10 degrees as a base. And then you take the maximum and minimum, divide it by 2 to get your average, your median there. And that's really a median. And this was, originally I was thinking of it as median heat units, cannabis median heat units. But when I'd had this discussion, I had feedback from one person who said it would be great if you could also keep track, or instead of keep track of average heat units, because the high and the low some days, especially at higher latitudes where we might have 18 hours of daytime, only 6 hours of nighttime, that affects that as well. Of course, photoperiod's another story for cannabis ripening, but the effective heat units is well documented throughout many crops, but in particular, wine grapes are, situated in places, zones that they have a chance of finishing. And there's a Winkler index of zones. And in BC, there was a BC Grape Atlas, but they would look at the degree ripening days, we would say up here, but in the States, it's a growing degree days. And that is a very simple calculation for how many hours or how many heat units are required to ripen a specific cutting. So if it's a Merlot cutting or a Cab Sauv cutting or a Pinot Gris cutting or a Gewürztraminer cutting, they can exist in quite different sites, because a very hot site is too much for Gewürztraminer, whereas a cool site, perfect for Gewürztraminer, might not get anywhere close to ripening a Syrah or Grenache or something. And it's the same with herbs. There's ones that are better matched to certain environments, of course. And it bears study, because you never see this, like in grapes, that heat unit's such a fundamental decision. And because it's a perennial crop that you may be, at the mercy of your selection for decades as that vineyard, gets old, you really want to, pick the right thing for the site. You really want to match to the site. Otherwise, you're going to have trouble. With cannabis, you can at least try another one on the next crop, but with grapes, it's a long-term commitment. So site selection on many levels matters so much for the genetics you're going to use in production there. And another, one of the world's top crops as well is corn or maize. And corn heat units are slightly more sophisticated formula, which I can't think of exactly off the top of my head, but you're welcome to look it up, corn heat units. And every corn cultivar is really, dependent upon X amount of heat units for germination, maybe 120 heat units for germination for it. And it might take 2,600 heat units to ripen. So, I mean, it's very well known. So they're concerned less with the days to ripening. They might think of it as 100-day ripening, but that'll increase or decrease based on the temperature of that season. So it's a very valid consideration. And I think it's really great if more and more people that are growing the same cuts, or even seed lines, but especially when they have the same cuts, if they put them out to finish at various locations, but also just to dabble with inside, or if they're in a greenhouse, and it's just a question of tracking. A lot of greenhouses or bigger indoors, they would have data loggers anyway, so they're probably already tracking it. And if you're a home grower, it's easy enough to track your highs and lows because generally speaking, you're setting your highs and lows because you're indoors and you have complete control of that climate. So if you ran a side by side with the same cutting with a 10 degrees difference in average, I would be surprised if you didn't see a significant difference. Which isn't to say, cook them all day. It might mean just have them a little warmer at night. So, you also have to still be able to balance your humidity. I've seen people try and warm them right up, but their dehumidifiers couldn't handle the extra load. So you've got to be careful, if you're doing it inside, of course, all aspects are still on the table. And the complication of comparing the heat units outside of the ripening degree days is they're not, it's totally valid anywhere's outdoor, just as it is for the other crops. But we have to think what triggers flowering in cannabis is usually photoperiod dependent, right? So this also affects the ripening of other plants too, but it's definitely a factor. So you could run the same temperatures in places with different photoperiods and have varying results. But it is an interesting thing to track, and especially in your own zone for your own knowledge. If you can start assessing, okay, well, this clone of skunk number 1, every time I plant it outside, it usually finishes the 3rd, 4th week of September. Maybe some years it goes longer, and in a really warm year might be sooner. And the first time I've noticed this, let me just share my anecdotal experience that first got me thinking about it. The first time I noticed a fairly, rapid ripening, I didn't attribute it to the heat at first. And this is when I was doing light depth greenhouses in the south of Switzerland. And they were very warm. They were, just polytunnels with good ventilation, but they would always be hotter than outside. So throughout the summer, they experienced some pretty high temperatures while we were doing the light deprivation. And light deprivation, for those who don't know, is when we force the plants into flowering sooner by keeping them on a neutral photoperiod of 12-12, and that has them flowering in the middle of summer when the light's still good, not waiting till the fall when the light's fading. So those light depth crops can be very nice quality. And what I was finding was plants I thought of as, 8-week plants indoors, they would be finishing in 7 weeks in the greenhouse. And I thought, why are they, they're really done. There's no point to leave them. They really are done. And I was thinking, that's so weird because I've grown that other one forever and it always took 8 weeks to look like this, So I thought at the time we were doing a photo period, wasn't exactly 12-12. We were doing 11-13 with a little longer night to see if that was helping them to force the flowering, And we attributed it to that extra hour of night, but we didn't think about, we weren't logging the temps or anything at the time. And in never gave it any more thought really after that until I was growing a crop on the equator outdoors, and I was planting some that I was familiar with, that I had a set idea in my head how long those should take to flower. And I thought, well, these ones here seem like, we did them inside. They're really high quality, high THC plants, over 30%, and they take 8 weeks or 60 days. Actually, those ones were bang on 60 days in the indoor. I put the same cuttings outside when it was very warm in the hot and dry season, when you can flower just about anything on the equator. And they were stunning that these plants got rock solid, absolutely done. Wasn't anywhere left for them to fill in. They were totally packed in, and they were done in 45 days. I'm like, how is this possible that they have ripened this quick? I wouldn't believe it if I hadn't done it myself, but they weren't getting chilly at night. So the days might be mid to high 30s, but the nighttime temperatures would still be like 24 in Celsius, I'm talking. So that was 24 is very warm at night. If you want to go jump in your pool and sit around outside, you won't feel cold. That's a very comfortable temperature, 24. And the plants, I'm sure it's because they just didn't have the chillier time at night. I think the extra heat assisted them in the rapid ripening, I thought. And rapid ripening might not be a great thing in grapes, for example, for wine grapes, because maybe you hit the sugars you want, or you burn or burn off the acid you need to, but the flavors don't have time to develop the phenolic ripeness. But really, on the cannabis ones that I've seen the accelerated ripening in the warm environments, there was really no detraction I could tell of. It wasn't quantified in any way, but it was absolutely convincing to me that this is a big advance. And I think a lot of people will really benefit from finding out they can run a little warmer nighttime. And also certain problems like powder mildew, they don't do well in the warmer environments. They're simply not a problem. If you're going regularly over 35, basically, mildew won't survive. So that's no, hot days help take care of it, but not having cool, wet nights also makes a big difference. So I think, clearly mildew can be dealt with as a resistance problem in genetics as well, but environment's great. If you can make the environment oppressive to your problems, you'll definitely not have to think about spraying strange fungicides or whatever. And most of us have zero interest in doing that, but as you know, there are plenty that will. So, and having more resistant genetics will be great for that overall. I mean, there are specimens out there, but it hasn't really become consistent that that it's a thing of the past. Mildew, it's still a relevant problem for a lot of people because it's not, mildew resistance isn't built into enough genetics yet. But just providing inhospitable conditions help, and part of that was that extra warmth. So I hope this give you a little insight into how we're going to start tracking genetics together. And I'll have the forms for you to check out on the site and on the forums that we have, and it'll be fun. So I think it may take decades before we really build up a great database of the heat in all the places, but I'm making sure to get some spread out testers right now and get their report. Simply, if you're logging your grow, just start logging your median heat units at least, but even better, your average heat units, where you can add up the hours of the day and divide by 24, over the same base threshold. And it'd be super interesting to see. And this open source project where anybody can post on the forums, post the result, and we'll start to collate them and, just keep it open source knowledge, because that's, there's nothing, it's good for everybody to know. It really is. And there's nothing proprietary about that. I think it's just interesting community knowledge. Anyways, thanks a lot for your time and listening to me ramble on about another Ganja Geek topic today. And wherever you are, I really wish you the best. Have a great one. Bye-bye.